Topic of this lesson is principle of moments. Moments. A force that turns a spanner in a clockwise direction in generally used to tighten a nut. The torque are moments of force so produced is called clockwise moment. On the other hand, to loosen a nut, the force is applied such that it turns the nut in the anticlockwise direction. The torque or the moments of force is produced is called clockwise moment. A body initially at rest does not rotate if sum of all clockwise moment acting on it is balanced by the sum of all anticlockwise moments acting on it. This is known as the principle of moment according to the principle as shown in the figure. A body is balanced if sum of the clockwise moment acting on the body is equal to the sum of the anticlockwise moment acting on it. Next, the center of mass. It is observed that the center of mass of a system moves as if its entire mass is confined at the point. A force applied at such a point is the body does not produce any torque in it. The body moves in the direction of net force without any rotation. According to the definition, center of mass of a system in such a point where applied force causes the system to move without rotation is called center of mass. The next, center of gravity. A body is made up of a large number of particles. Earth attracts each of these particles vertically downwards its center. The pull of the earth acting on the particle is equal to its weight. These forces acting on the particles of the bodies are almost parallel. The resultant of these parallel forces is the single force equal to the weight of the body. A point where these resultant forces act vertically downwards, the center of the earth is called center of the gravity and it is denoted by G. A point where the whole weight of the body appears to act vertically downwards is called center of gravity of body. It is useful to know the location of the center of gravity of body in problem dealing with equilibrium. Center of gravity of irregular shaped and thin lamina are couple. To find the center of gravity of irregular shape, take an irregular piece of a cardboard, make hole A, B, C as shown figure 1, 2 and 3. Support the cardboard on the nail through one of the hole so that the cardboard can swing freely about A. The cardboard will come to rest with its center of gravity just vertically below the nail. Vertically line from A can be located using a plumb hung from the nail. Mark the line on the cardboard behind the plumb line. Repeat it by spotting cardboard from hole B. The line from the B will intersect at a point G. Similarly, draw another line from the hole C. Note that the line also passes through the G. It will be found that all the vertical lines from the hole A, B and C in figure number 1, 2 and 3 have the common point G. This common point G is the center of gravity of a cardboard. Couple. When we try turn a vehicle, we apply force that produce a torque. This torque turns the steering wheel. These forces act on the opposite side of the steering wheel as shown in the figure and are equal in the magnitude but opposite in the direction. These forces from a couple. A couple is formed by two unlike parallel forces of the same magnitude but not along the same line. A double arm spanner is used to open a nut as shown in the figure. Equal forces each of the magnitude F are applied on end A and B of a spanner in opposite direction. These forces form the couple that turns the spanner about point O. The torque produced by both the forces of the couple have the same direction. Thus the total torque produced by the couple will be the total torque of the couple F multiply OA plus F multiply by OB. Note, take the common F on F into OA plus OB. OA plus OB is equal to AB. So we put the value of AB instead of OA plus AB. It become F multiply AB. The torque produced by the couple of force F and F separated by distance AB. The torque of the couple is given by the product of one of the two forces and the perpendicular distance between them.